Okay, welcome to Chapter 12, Lesson 3, Trigonometric Functions of General Angles. Now, the objective here is to define trigonometric functions of general angles. Now, you remember from the last lesson that we started doing trigonometric functions of acute angles, and so we're dealing with angles only in quadrant 1. This lesson is taking it up a notch, and we'll be dealing with the same functions, but now we're going to be working with angles that are obtuse in quadrant 2, quadrant 3, or quadrant 4. Okay, so in lesson 12.12, you learned the definitions for the 6 trigonometric functions for acute angles. Now you'll extend these definitions to angles of any measure. As you did with acute angles, we will place the angle theta in standard position as shown in each diagram below. So we are still going to put the initial side on the x-axis and then swing it counterclockwise to wherever it stops. We're going to choose a point P, any point on the terminal side of angle theta, in each quadrant, and let R be the distance of OP. Okay, OP. OP and OP. Now this gray box summarizes some of what we need to know. Let's look at it. For any angle theta and any point xy on the terminal side, we have the sine of theta is y over r. Same. Cosine of theta, x over r. Y over x for the tangent. The cosecant is r over y. Remember, the sine and cosecant are reciprocals. Secant and cosine, reciprocals. Cotangent and tangent are reciprocals. So that's no different, see? Look over here. Same as what we dealt with originally. So it works in any quadrant. So the first example, let's go through it. It says, find the values of the 6 trigonometric functions of an angle theta in standard position whose terminal side passes through 8, negative 15. Okay, 8, negative 15. That is going to be a graph that looks like this guy, because it's going to go 8 and then down 15. So we're going to be dealing in the 4th quadrant. Okay, so first make a sketch similar to the third one above, like I just showed you. And then x is 8, y equals negative 15. Since r is the distance between the origin and that point, 8, negative 15, you can find r by using the distance formula. You got to remember that. So it's the difference in x squared and the difference in y squared. And since it's 0, it's going to be 8 minus 0 squared and negative 15 minus 0 squared, which is 17. So the distance of that line, the distance of this line, for 8, negative 15 would be 17. Okay. So the hypotenuse is 17. So the sine of angle theta is y over r, negative 15 seventeenths. Cosine, x over r, 8 seventeenths. Tangent is y over x, negative 15 over 8. Then flip them for the reciprocal functions. Cosecant would be negative 17 fifteenths. Secant would be 17 eighths. Cotangent would be negative 8 fifteenths. Okay, in the definitions above, r is always positive. Therefore, the signs of the functions of theta are determined by the signs of x and y. And these signs depend only on the quadrant of the terminal side of theta as shown on the next page. Okay. Let's check that out. What do we do? Okay. The sine and cosine functions are defined for all angles, but the other 4 functions are undefined for certain quadrantal angles. Okay, so if we have the sine and the cosine will work for any angle, but the other 4 won't work in certain quadrants. So look at this. The sine and the cosecant in quadrant 1 and 2 will be positive, negative in 3 and 4. The cosine and the secant would be positive in quadrant 1 or in quadrant 4, but negative in quadrant 2 and 3. The tangent and cotangent will be positive if it's in the first or the third quadrant, and negative if it's in the second or fourth quadrant. You can always fill this thing out by thinking about these pictures. If it's in the first quadrant, notice everything's positive. If it's in the second quadrant, then only the sine and the cosecant are going to be positive. Everything else will be negative. If it's in the third quadrant, here, third quadrant, then it's going to be, the only thing positive is the tangent and cotangent, because it's the negative, negative. Then the fourth quadrant, so you see how this works. You can always just think of the graph and then figure these out, because you know what sine, cosine, tangent are, and then the cosecant, secant, and cotangent are the reciprocals. Okay, let's look at this next example. Okay, it says determine which functions are defined for a 180-degree angle and find their values. 180-degree angle. Here's the picture. Initial side, terminal side. Place the angle in a standard position. So we did that. Choose a point on the terminal side, okay, and it says just pick a point like -1, 0. So x is -1 and y equals 0, and r would also be 1. The distance from the origin to our point. Always positive. Okay, so the sine of 180 degrees is y over r. 0 over 1, that's 0. The cosine of 180 degrees is x over r. -1 over 1 is -1. Okay. Tangent of 180 is the y over the x. 0 over -1, so that's 0. Now the cosecant is the reciprocal of the sine. 1 over 0. But you can't do that. So it's undefined. The cosecant of 180 degrees doesn't exist. The secant of 180 degrees is okay. It's r over x. That's -1 again, same as the cosine. And then the cotangent is the reciprocal of the tangent, and it's -1 over 0, but that's undefined because you can't divide by 0. So the cosecant and the cotangent for 180 degrees is undefined. Okay, quadrantal angles. Now, if theta is not a quadrantal angle, and remember, I misstated it earlier, but a quadrantal angle is an angle that has its terminal side on one of the axes. So if theta is not a quadrantal angle, there is a unique acute angle, alpha, which corresponds to theta, formed by the terminal side of theta and the positive or negative x-axis. When theta is in standard position, we call alpha the reference angle of theta. We can use diagrams like these to help us find a reference angle. So let's think about this. If the alpha is always going to have the x-axis as its reference point. So let's look at this. So if theta is 300 degrees, the red one goes like this, all the way around, then alpha is our reference angle. 60 degrees. It's an acute angle to help us track what's going on. Now on this one, 225 degrees, we have this 45-degree angle is our reference angle. It's always an acute angle off the x-axis. Now if we have -210, then this 30-degree angle is our reference angle. And if we cycle on this one, and you go 420 degrees, then our reference angle is 60. Okay, example 3. Find the measure of the reference angle alpha for each given angle theta. Okay, so if we have an angle 140 degrees, what would the reference angle be? Well, you can sketch it out. 140-degree angle is going to be over here somewhere, like this, right? Because this would be 90, and this would be 50, and this would be 40. So the answer is 180 minus 140, and so 40 is our alpha for 140 degrees. Okay, now what if it was 300 degrees in 10 minutes? Oh boy, that's in quadrant 1, 2, 3, 4 over here. And so we're going to do 360 minus 310 minutes. So then we would get 300 and 59 359 degrees in 60 minutes minus 300 degrees in 10 minutes. And so we'll get 59 degrees, 50 minutes. Okay? Like right here, that's what it's saying. Since theta is in quadrant 4, alpha is 360 minus theta. And you change 360 to 359.60 so you can deal with the minutes, and there it is. Okay, now theta is a negative 135 degrees. So we're going to find the positive angle that's coterminal with negative 135 by adding 360, so it's 225. So then we would do 225 minus 180 and get 45 degrees. You can use the reference angle to draw a reference triangle for any angle theta, and then use the reference triangle to find values for the trigonometric functions of theta. So we're using this whole concept of the reference angle, the alpha, to help us with the actual theta. For example, OMP, this triangle right here, we'll see that the cosine of A is the absolute value of x over r. And the cosine of theta is x over r. So, cosine of theta is x over r, which is plus or minus the absolute value of x over r. It's going to be plus or minus the cosine of alpha. The same thing works for the other trigonometric functions and for angles in other quadrants. Therefore, each trigonometric function of theta is either equal to the same function of alpha or equal to its opposite. So if you're working with this reference angle and you find the sine or the cosine or the tangent, it's going to be the same as theta, just positive or negative, depending on which quadrant it ends up in, which is why we learned this little chart. Think through this. Okay, so if the sine of theta is going to be plus or negative the sine of alpha, the cosine of theta is plus or minus the cosine of alpha, and so on. Alpha is the reference angle of theta. The correct sign is determined by the quadrant of theta. So we can figure out the cosine of 200 degrees as a function of an acute angle. So what's the thinking? The reference angle of 200 is 20 degrees, because 200 is just past the x-axis on the negative side in the third quadrant, so it's 20 degrees under. And since it's in the third quadrant, the cosine is negative, so the answer is the negative cosine of 20 is the same as the cosine of 200. Okay, next examples. Find the exact value of the following: the tangent of 330 degrees, the cosecant of negative 225 degrees. And you're going to go back to that chart from the last lesson that deals with the standard 30, 60, 90 right triangle or the 45, 45, 90 right triangles. So what's the reference angle for 330? It's 30 degrees. So it's going to be the negative tangent of 30, which is this. Same. Okay, the reference angle of this negative 225 is 45. And negative 225 is second quadrant angle, so the cosecant's positive. So we're going to do the cosecant of 45, which is the square root of 2. So that's how that works. Oh, we're not done yet. Don't go away. Okay. Got one more page together. Okay, now, the identities that we proved. Remember that the sine of an angle over the cosine of the angle is equal to the tangent angle, and then the reciprocal of that, and the squared of the sine plus the square of the cosine is equal to 1. That works still for any angle, as long as the cosine doesn't equal 0. Then these identities will still work. Okay, so example 6. Let's see what it says. Find the 5 other trigonometric functions of theta if the cosine of theta is negative 2/5, and then theta is bigger than 180 but less than 360. Okay, so we gave us this restriction so we can fit it into its quadrant. That's a third quadrant angle. Okay, use the sine squared theta plus cosine squared theta to equal 1. The sine squared plus negative 2/5 is 1. So 1 minus that, we get 21/25 is the squared. Square root it. We have the square root of 21 over 5, or the negative square root of 21 over 5. Now, we know that the cosine of theta is negative, and that the angle is bigger than 180 and less than 360. So it's a third quadrant angle, and then the sine of it is negative. So it's negative square root of 21 over 5, and then we plug in the sine and the cosine to get the tangent. And then the last three are simply the reciprocals of the sine, the cosine, the cosine, the sine, and then the tangent. Okay, that's it. Thank you guys, and let me know if you have any questions as you start your work.